So in this video, I'm going to go over problems that are similar to what you may see on the Unit 3 test. So this first question asks which ordered pairs lie on the graph of the exponential function f of x equals 2 times 1/2 to the x. So one thing to realize here is that f of x is y. So what you can do is you can plug this into your calculator and you can go to second and then click table to find the table of values for this function. Then you can verify whether these points are on your table. Another way to do them is to plug these values in for x and y. So I'm going to start off with a, so that's going to tell me that 2 equals 2 times 1/2 to the 0. Remember, anything to the 0 power is 1, so this is 2 equals 2 times 1, which is correct. So that means that is a point on my graph. So let's check the other points. So if we do that, we get 1 equals 2 times 1/2 to the 1. So 1 equals 2 times 1/2 is correct because 1 equals 1. So that is a point on my graph. If I plug in C, I get 0.25 equals 2 times 1/2 to the 3. So 0.25 equals 2 times 1 over 8, which is correct because 0.25 equals 2 times 1 over 8, which is 1 over 4. So that's correct. So C is also a point on my function. So then if I try D, so I get -1 equals 2 times 1/2 to the 4th. So I get -1 equals 2 times 1 over 16. And that equals -1. That says that -1 equals 1 over 8, which is not true. So D is not included. So A, B, and C are points on my function. So you can do this one of two ways. You can either do this by graphing it on your calculator and checking the table, or you can plug in each point individually and verify that the x and y values make the function true. So this asks which graph represents the value, the graph of 3 times 2 to the x. So remember, we have an equation in y equals a times b to the x form. So that a is going to represent the initial value. Okay, so that initial value is going to be the y-intercept. So if we look at the graph, the one that has a y-intercept of 3 is actually the graph of C. But let's double check another point to make sure. So if we look at this, the point 1,6 is on my graph. So if I plug that in, I get 6 equals 3 times 2 to the 1. So if we simplify this, we get 6 equals 3 times 2, which is 6 equals 6. So that verifies that C is the correct answer choice. So this says, what is the range of the exponential function represented by this graph? So it's asking me for range. Remember, range means y values. So I'm going to go ahead and eliminate any answer choice that talks about x. Okay, so I want to know what are the y values of this function. So I can see here, it gets really, really close to this line right here. This line that goes through y equals 1. So it gets really, really close to 1, but then it exists above 1. So that's why it's y is greater than 1. It would be y is less than 1 if my graph existed below that line. Since it's above, it's going to be y is greater than 1. So this problem says that an orchard produces 3,500 apples in 2020. They plan to increase their production by 3.5% every year. Write an exponential function that models the number of apples produced by the orchard x years after 2020. So we have 3,500 apples. They're going to increase their production by 3.5%. Remember, anytime you see that percentage sign, we know we need to use the form of the equation a times 1 plus or minus r to the x. So it says that it's going to increase their production. So I know that I'm going to need to use the form y equals a times 1 plus r to the x. So now I just need to figure out what values go here. So a is the starting value or the initial value. So that means that I'm going to use 3,500 because that's where it starts off at. So it's going to be 3,500 times 1 plus r. I need to change to a decimal. So it's 3.5%. Remember, I need to move the decimal to the left twice, and that's how I change it to r equals 0.035. So this is going to be 1 plus 0.035 to the x. So it'll be y equals 3,500 times 1.035 to the x. That's my equation. So this asks me, what is the value of the y-intercept of the graph of y equals 226 times 1.25 to the x? So the first choice you have is to graph it and look for where your graph crosses the y-axis. Okay, that's one way that you can find the value of the y-intercept. Another way is to realize that the y-intercept occurs when x equals 0. So the y-intercept will be at 0, comma y. So what you do is you can plug in 0 to this equation. So you get y equals 226 times 1.25 to the 0. So that's y equals 226 times 1. So y equals 226. So that is the y-intercept. The y-intercept will be at 0, 226. And you can verify this by graphing your function. So this asks which equation describes the asymptote of this exponential function. So if I was to draw in the asymptote, it would be right here, right? Because my graph gets really, really close to this line, which is y equals 2, but it doesn't actually cross it. So that's why y equals 2 is the correct answer. Don't choose x because x is a vertical line. Okay, this doesn't have a vertical asymptote. This has a horizontal asymptote where it's getting closer and closer to y equals 2, but not actually crossing it. So this says that a new computer costs $2,000. Its value decreased by 13.5% every year after it's purchased. Which function models the value of the computer X years after it was purchased? Okay, so here's my red flag, right? I see that percentage sign. So I know I need to use the form of the equation, a times 1 plus or minus r to the x. So here it says decreases. So I'm going to say this is y equals a times 1 minus r to the x. So what we need to do is figure out what we need to plug in here. So 2,000 is going to be my starting value. So I have 2,000 times 1 minus that r, that 13.5%. I need to convert to a decimal. So that's going to be r equals 0.135. So 1 minus 0.135 to the x. So that's going to give me y equals 2,000 times 0.865 to the x, which is answer choice C. So this tells me that this has a table giving the value of investments 4 years after the initial investment was made. The data can be modeled using an exponential function. Based on the data, what is closest to the value 10 years after it was made? So I need to write an exponential function, and it gives me a table of values, okay? So when I do that, I need to do the exponential regression on my calculator. So what I do for years, that's my x value, so that's L1, okay? My investment value is L2, which is my y values. So what I do is I go to Stat, and then hit Enter on Edit, and you're going to enter these values into L1 and L2. Okay, so go ahead and enter these values into L1 and L2. Remember, you have to click Enter after each value to go to the next place in your table. Okay, so then once you've done that, double check your table of values and make sure that you've entered everything correctly. Then click Stat, arrow to Calculate, and you're going to scroll down until you see option 0, which is exponential regression, EXP reg. Okay, so scroll down until you see EXP reg, and you're going to choose that and hit enter, and hit enter on calculate, and it'll say y equals a times b to the x, and it says a equals 2,000, I'm just going to round, and b equals 1.13. So when we write the equation, we get y equals 2,000 times 1.13 to the x. Well, here it doesn't just ask us for the equation, it asks us for a specific value. We want a value after 10 years. So 10 is our value of x, so we're going to plug that in, and we get 2,000 times 1.13 to the 10th. And when we do that, that should give you a value that's approximately $6,789.13. So yeah, just a reminder, steps for exponential regressions. Stat, enter your values into L1 and L2. Choose 0 for exponential regressions.